All right, today we're going to review rate of change slope, and then we're going to review graphing lines. Some of this will be review, some of this will be brand new to you. So please take notes either in your notes or on the note paper that was given to you. Both of those things you will need to show to the guest teacher before you will be allowed to get your homework. All right, so some vocabulary in notebook. I'm not going to spend a lot of time on slides where you're going to write things down, so you just need to pause and take notes as you need to. So the rate of change shows the relationship between two changing quantities, and the rate of change is the change in the dependent over the independent variable. Or in other words, the rate of change is the change in y over change in x. We talked about this a little bit when we were talking about linear functions. And so we just need to remember that it's the change in y over x. Y comes on top, x is on the bottom. The rate of change is also called the slope of the line. And the rate of change slope is rise over run. And rise, if you think about it, if you're going up, that's going in the y direction, or down is in the y direction. And run, left or right, is in the x direction. So that's why y goes on top and x goes on the bottom. Okay, on your note page, these are there for you. So to find the slope, it's the change in y, rise, over the change in x, run. So you have to find two perfect points, and perfect points are where the line goes through the corner of a box perfectly. If you don't have perfect points, it's going to be really hard to find the slope because you don't know exactly what the point is. If you have a perfect point, you know exactly what the point is. So here is a perfect point, and here's a perfect point. All right, so we count rise first, always count up or down first. So we're going to start at the lower point and go to the higher. You can start at the higher and go to the lower. It does not make a difference as long as you are counting up or down first. So we're going to rise. 1, 2, hold on. Okay, so you're going to rise 1, 2, 3, 4, 5. This is having a hard time. 5, 6, 7, 8. I think that's 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're rising 8, and then we're running from there 3. 1, 2, 3. So the slope is 8 over 3. The rise was 8, the run was 3. Okay, the second one here is a little bit different. When the line is going down from left to right, this line is going down, okay, and this one was going up from left to right. When it's going down, it's going to be a negative slope. And so again, we have to find two perfect points on the line. I think there's a perfect point right about there and a perfect point right down here. Okay, so again, we're going to count rise and run. So rise is 1, 2, 3, 4, 5, 6, 7. And the run is 1, 2, 3, 4, 5, 6. So our slope is negative, because it's going down, 7 over 6. All right, I want you to try this on your own, write it on your note paper, and then pause the video, and then check back in only when you have found the slope. All right, so you should have paused the video. You should have found the slope on your own. The first one is 2 over 5. And the second one is negative. If you forgot the negative, then you are wrong. 2 over 1, 2, 3, 4, 5, 6. Negative 2 over 6, which is the same as negative 1/3. Okay, you should notice there's also a perfect point like right in the middle of this graph. It just wasn't labeled. Okay, so I always try and find perfect points that are right next to each other so that I don't have to simplify later. Okay, in your notebook, this is super important. So we can find the slope between 2 points without graphing. And it is, again, just the change in y over the change in x, but there's a formula for it. It's called the slope formula, and it uses 2 points. Point 1, we always label as x1, y1. Point 2 is x2, y2. That just means that we're defining the first point and we're defining the second point so that when we put in our formula, we do the right thing. So the formula is y2 minus y1 over x2 minus x1. And that will help you find the slope between any 2 points. So my thinking through this, what is the slope of the line through -1, 0 and 3, -2? So again, we always want to label our points. So like if I was doing this, I'm going to label the first point for myself as x1, y1, and the second point as x2, y2. Once I label, it's just a matter of substituting in, so it's not super complicated. So we start with y2. I labeled y2 as -2, so -2 minus y1, which is 0, over x2 I labeled as 3, minus x1 is -1. And so you have to realize when you're plugging in a negative, we've talked about this before, you have to put parentheses around it. So minus -1. So then we just simplify. -2 minus 0 is -2. 3 minus -1 is like 3 plus 1, so that's 4. So my slope is -2 over 4, which is equivalent to -1/2. When we're dealing with slope, it is kind of important that we simplify. I won't necessarily count you wrong if you don't simplify, but work on simplifying when it comes to slope. All right, you try this one, pause it, and then check in with me when you are done. All right, so you should have paused and you should have gotten the slope. Make sure you have the right thing. So I would probably again label x1 at y1, x2, y2, and then I would simplify. So -1 minus 3 over 4 minus 1. So -1 minus 3 is -4, and 4 minus 1 is 3. So my slope is -4/3. We do not ever write slope, ever, in a mixed number. We keep it improper every time because we need to know the rise and we need to know the run. If you put it in a mixed number, you can't figure out the rise and the run quickly. All right, these lines. So slope of each of these lines. We're going to draw them in our notebooks. I'm just going to tell you today. When you have a flat line, okay, slope represents the steepness of a line. And so when you have a flat line, it has no steepness at all. Like it is very flat. It is not steep. If you set a ball on the line, it would not roll because it is straight up flat. And so when you have a horizontal line, the slope is 0. So the slope of this one is 0. And I would draw something like a horizontal line in your notebooks to signify that that is 0 slope. On the converse, when we have a straight up and down line, that is like the steepest a line can get. It is a 90-degree drop if you were to drop off that line. And you couldn't walk up or down it because it is straight up and down. So when you have a vertical line straight up and down, the slope is undefined. undefined. Okay, that is an undefined slope. It is as steep as a line can get, and therefore it is undefined. Okay, you do these in your notebooks and pause it and then check with me. All right, so you should have paused. You should have got something, like a number answer, okay? The first one, you would get you'd get positive 5 over 0, okay? You cannot divide by something, by 0 in the denominator ever. You can never divide anything by 0, and so this is an undefined slope. The other way around, you would get 0 over 6, okay? 0 divided by anything is 0, so this is 0, 0 slope. All right, so each pair of points lies on a line with a given slope. Find x or y. And so we're just going to substitute in what we know, and we're going to solve for what we don't know. So we're going to start with slope. We have 1/4. And we know that slope equals y2 minus y1 over x2 minus x1. Man, this pen is not working, sorry. Okay, so y2 is -2, so -2 minus y1, which is 9, over x2, which is just x, minus x1, which is -12, and because it's negative, we put it in parentheses. So we're going to simplify what we can. So 1/4 equals -2 minus 9 is -11 over x plus 12. Okay, then this is just like a proportion. We've solved these before, so we cross multiply. All right, proportional equations, we cross multiply. So -44 equals x plus 12. And then we solve for the variable. Subtract 12 from both sides. -56 equals x. So x is -56. Okay, you try this one, pause it, try something, and then check back in with me. All right, you should have paused, you should have tried. Okay, we would write -1/2 equals y minus 5 over 2 minus 3. So negative. When you have a -1/2, that means one of them is negative. Either the 1 is negative or the 2 is negative. It doesn't matter. So I'm going to put it onto one of the numbers so that when I do my proportion, I don't get confused. So I'm going to say -1 over 2 equals y minus 5 over -1. So then I cross multiply. -1 times -1 is 1. So 1 equals, then we have to take 2 times y minus 5. And we solve. So 1 equals 2y minus 10. So 11 equals 2y. So y equals 11 over 2. And I have run out of room. All right, so now we're going to talk about slope-intercept form and graphing equations. So write these things in your notes. Pause the video because I'm going to move on. So a linear equation is an equation that models a linear function, aka it's a straight line. Y-intercept is the y-coordinate where the graph crosses the y-axis. You can use slope and y-intercept to write the equation of a line. This is called slope-intercept form. And there's 3 different forms that we're going to work with. So this one we need to remember really well. So M represents the slope, B represents the y-intercept. So in this equation down here, 5 is the slope, -2 is the y-intercept. All right, on your notes page, you're going to graph this with me. So when you graph, you always start with the y-intercept. So the y-intercept is -1. So I'm going to put a dot at -1. Then I'm going to count my slope. So I only have 2, and for slope I need a rise and a run. So I can change this from 2 to 2 over 1. So my slope is 2 over 1, which means we rise 2, we run 1. So we're going to start going up. We go up 2 over 1. And it will not make a dot. There we go. Up 2 over 1, up 2 over 1, up 2 over 1. And once we run out of room, we go down back to the y-intercept and go the opposite way. Down 2 over 1. Down 2 over 1. Okay? And then you should be able to use your ID or something to make a straight line, but the line should go through the points and have a slope of 2 and a y-intercept of -1. Okay, I'm going to do the first one with you. If you think you can do it without me, great. Pause it and then you can check. But the difference between this one and the last one is that the slope is negative. So when it's negative, that means it needs to be going down when you graph it. So this time we're going to go up 3 into the left one, and then down 3 into the left one. Until we get a line that is going down because it is negative. Okay, try the next one, pause it, try it, check it with me. I know you run out of room, but you can still estimate where 8 is. Two, 3, 4. Okay, so it should look similar to that. Okay, writing an equation of slope and y-intercept is the same concept. So we find the y-intercept. So B in this case is -3. And then our slope, we count. So our slope, we're going, here's a perfect point right there. So we're going up 2 over 1. So our slope is 2 over 1. So our equation is y equals 2x minus 3. Okay, I know I'm like teaching you a lot right now, but you'll be okay. So write the equation of this line, pause it, check it with me. So you should have paused, you should have gotten y equals -1/2 x minus 2. Okay, the slope's going up 1 and over 2, so that's a 1/2. Okay, this one, when you have a horizontal line, all right, like I said, slope is 0, so y equals 0x minus 4 because the y-intercept is -4. So essentially, we don't write the 0x, all right? We have y equals -4, and that is it. That means at every single point along this line, y is going to be -4, which is true. There's no slope. This one is the weird one. So when you have an undefined slope, this is the only time you're going to have x equals a number. So x equals -4 when you have an undefined slope. Okay, writing an equation of a line from a table or from a set of ordered pairs is not super complicated. So we pick 2 points. Okay, doesn't really matter what 2 points. I'm going to pick the first 2 here because then we can use the slope formula. So we'll say this is y2 and this is y1 and this is x1 and x2. So -3 minus -7 over 4 minus 2 equals 4 over 2, which equals 2. So from here, though, we have to find the y-intercept. And so to find the y-intercept, we're going to substitute what we know into our equation. So right now, we have y equals, we know the slope is 2, and we do not know the y-intercept yet. All right? But with a table, we can follow a pattern, all right? Do I want to do the pattern? Yeah, okay, so the pattern is 2. So that means like y is changing by 2 while x is changing by 1. And so, okay, you could follow a pattern. If you understand that, do that. If not, I'm going to actually show you the next way to do this. So we also know that these 3 points are on the line, and so we're going to substitute one of the points in for x and y and solve for b. So let's substitute in 2 for x and -7 for y. So negative, because that's one of the points on the line. -7 equals 2 times 2 plus b. -7 equals 4 plus b. -11 equals b. So our equation of this line is y equals 2x minus 11. Okay, we're going to skip that one, and we're going to do it with 2 points. It is the same concept with 2 points. So this is y2, x2, x1, and y1. So we substitute in -8 minus 1 over 5 minus 2. So -9 over 3, which equals -3. So we know that y equals -3x plus b. We don't know what the y-intercept is yet. And so we're going to substitute in one of the points. I'm going to pick 2 and 1. Doesn't really matter which one. So y is 1, -3 times 2 plus b. So 1 equals -6 plus b. 7 equals b. So our equation is y equals -3x plus 7. All right, you can try the last one, okay? And I want you to go show the guest teacher your notes, and then you can get the homework. If you have specific questions and you're really confused, you can email me. I don't know if I'll be able to respond right away, but you can email me.